Right, okay. All right. All right. Okay. So now we'll start the story. Right, okay. So now first important thing is now this is a kind of fast track session that I'm planning to conduct for upcoming two, if not maximum 2.5 months. Right, this is mainly for 2027 batch students who could not cover the previous sections properly. Even though you cover the previous sections properly, but still you have lots of doubts. Sometimes you don't understand at all. In that case, these sessions definitely will give you an idea about entire lesson. Especially, I'm planning to complete unit 1, especially unit 2 stories in this session. Right, very briefly, but without missing the theories, by completely discussing all the theories, and we are going to do questions as well, right? But we are not going to do questions like theory classes, but we are doing enough number of questions to understand every chapter. Okay, so now what I would say is, now today we are starting the class today, but generally class time is here after 6 p.m. to 7:30, maximum 6 p.m. to 8 p.m. Okay, so now first important thing I want to explain is, right now, when we go for when we invest something, right, we should get the return. If we invest something and if we don't get the return, then there's a problem. Likewise, now when you are joining for a session, if you really feel like the session is important, join, and always try to get something back from every session. Therefore, you are investing your time, therefore learn something from every session, right? Learn something from every session. That is important story. Okay, so now I will brief some stories, and today we'll start from vectors. Then next day I will start units and dimensions, some theory sections also I will revise in this session, right? Now we are going with a short method way, right? But we are not missing any single theory. We are covering everything properly, right? Okay. Now first story. Now till the class finishes, we are not doing a long hour class today. Therefore, only maximum 1.5 hours. Therefore, I don't think that's going to be a tiredful class for you all, right? So therefore, stay attention and keep your focus, and we'll learn something. That's it, right? Okay, we'll start the idea. We'll start the idea, right? If you have doubts on anything, you can clarify. You can ask from me, right? We'll start the idea, right? Okay, all right. Okay. So now we know that I think most of you have covered mechanics. Some of you might have covered, but could not understand the ideas. Right. Normally, the first chapter is vectors. We are starting from vectors theories. Okay, we're starting from vectors. Every point matters. Therefore, stay focused till 9:30. Okay, we are starting from vectors. Unit 2 mechanics. Unit 2 mechanics. Starting from vectors. I will share the question PDF through the WhatsApp group. You can refer the question PDF when we are doing questions. Okay, Unit 2 mechanics. Right. So the subchapter is vectors. Today, overall idea, vectors, vectors theories, vectors. Okay. Right. Now, if I give a small brief about vectors, what is a vector? Before understanding vectors, you all should know that what does it mean by physical quantity? What does it mean by physical quantity? Physical quantity? Physical quantity. Can you explain what is physical quantity? They don't ask the definition of physical quantity, but we should know that. What does it mean by? If I briefly explain physical quantity, means remember, whatever the change that we can observe in the surrounding, if you can measure it qualitatively or quantitatively, that is what we define as physical quantity. What are the changes happening in the surrounding? If you can measure it qualitatively or quantitatively, then they are what we call as physical quantity. Now, for an example, now I don't go deep and I don't explain. For an example, mass is a physical quantity. We can clearly see the difference between two objects' amount of matter. If I consider the marker and if I consider the iron ball, I can clearly see a kind of significant difference between them. So therefore, we define mass as a physical quantity. Mass, volume, density, distance, displacement, time, acceleration, right? So we can categorize every change is happening in the surrounding. We can give name for that. Then they are what we call as physical quantity. For our convenience, what we are doing, we are dividing all the physical quantities that we identified. We are dividing into two subcategories. The first subcategory, we know that. O levels also we learned that. That first subcategory is scalar. Second subcategory of physical quantity is vectors. First subcategory is scalar. First subcategory is scalar. Okay, here. First subcategory, scalar. Now, what is a scalar? How do we differentiate a scalar with a vector? Scalar. Second subcategory is what? Vectors. 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 Right? Scalar, vector. Now, scalars means remember, there are some physical quantities. To describe the physical quantity, only magnitude is sufficient. For example, if you consider mass, we all know that. To describe the mass, for example, we know that mass is measured in kilograms. Right? When you go for a shop and if you're asking a dal, I need 1 kg, 1 kilogram of dal, the person in the shop is able to understand what you are explaining regarding the mass. I need 1 kilogram mass. To describe some physical quantities, if the magnitude is sufficient, then we call it as a scalar. The best example for scalars, we all know that. Example for scalars, we all know that mass. Then volume. Mass, volume. Then time. Then time. Right? Likewise, I can tell set of physical quantities for scalars. Then time. But there are physical quantities, to describe them only magnitude is not sufficient. You should mention the direction also. The best example for a vector, right? The physical quantities which require magnitude and direction to describe the physical quantity clearly is we call as vectors. The best example for a vector that we all know is force. Because we know that force is measured in newtons. Magnitude, now if I say that apply 5 Newton force on the object, you might have problems. I understand I want to apply a force having a magnitude 5 Newton, but exactly what direction? I can apply a force to an object, right side direction. I can apply force to an object, left side direction. I can apply the force upward direction. So exactly which direction do you want to apply that force? Right? Then we realize some physical quantities only magnitude is not sufficient. In that case, we should define the direction also. They are what we call as vectors. Vectors. So scalars, remember, only magnitude. Scalars having only magnitude. Vectors having magnitude and direction both. Vectors having magnitude and direction both. Magnitude and direction both. Our target is learning about vectors, but I'm starting from the beginning properly. Direction. Direction. Okay, direction. Okay. Example for vectors, I will write few examples. One is force. Then I can say that linear momentum, sometimes you are not very familiar about this physical quantity. We all know forces. Linear momentum is also a physical quantity to measure, physical quantity vectors. Linear momentum is also a vector quantity. Linear momentum. Right? Okay. And we can tell that torque is also a vector. This is enough. Okay. Right? Only magnitude. Scalars having only magnitude. Only magnitude. Only magnitude. Right. Magnitude. So then we are planning to learn vectors theories clearly. A very clear vectors means physical quantities having magnitude and direction. Right. Now we can learn more about vectors. Now vector notation. Okay, the story. Every story is important. First of all, we'll do the theory as soon as possible. Now vector notation. There is a way of rotating a vector. Right? There's a way of rotating a vector. There's a way of rotating a vector. Okay. First story. Now very carefully focus and learn, right? If you are spending 5 minutes, at least for that 5 minutes, somehow stay focused and learn. Don't spend even 5 minutes. Don't spend wastely. Time is very precious for you people doing A levels. Therefore, we very focusfully listen what I'm explaining and we'll cover everything properly from the beginning. Right? Okay. Now story. Now vector representation. Next theory. Next theory point is graphical representation of vector. Graphical representation graphical representation of a vector. Right? Okay. Generally, we define the vector graphically by using a line segment. But remember, length of the line segment is proportional to the magnitude of the vector. And also remember, direction of the vector we represent by drawing an arrow on the line segment. Okay? For an example, remember, vector magnitude is represented by a line segment, length is proportional to the magnitude. Its direction is represented by, the direction of the vector is represented by the arrowhead marked on the line segment. See? For an example, there is a vector like this. There's a vector in this direction. The length of this line is proportional to the magnitude of the vector. Direction of the vector is represented by this arrow. Now vector notation. So we are giving a name for this line segment with the arrow. That is vector notation. We can use two different vector notations. The one way is you can use two capital letters and you can notate a vector. Notating means what? Giving a name. Giving a name for a vector. The first method is you can use two capital letters and you can notate a vector. The second method is you can use a simple letter to represent a vector. So, if I give two capital letters, look here. Now, arrow direction. Here to here, the arrow is flowing. This point is point capital A. This point is point capital B. Then we can name this vector as what? Vector AB. So, when you're writing that vector AB, the name of the vector, notation of the vector AB, definitely you should put an arrow head on top of AB. You must put an arrow on top of AB. This is the vector notation by using two capital letters. So I can say another vector like this, this vector. I can tell that capital letters, okay? Capital C, capital D. What is the notation of this vector? It is vector CD. Vector CD, definitely you should put an arrow on top of CD. If not, there is another way of representing the vector using one single letter. Now, in the beginning, we have to learn the stories theories, because without learning theories up to a certain level, we are not able to do questions. First of all, we want to understand the behavior, the nature of the vectors. Then only step by step only we can understand the stories, question patterns, then past paper questions, model papers. That's how we are learning stories, right? In the beginning, you should have a very clear focus and patience to learn every point clearly, step by step, understanding. Okay, now we know it is a vector. Another way how we are noting the vector, right? Therefore, stay focused today. Okay. The second way of rotating a vector is using one single letter, right? I can define a simple letter, simple A, but remember, you must put a right. You must put a small horizontal line below the simple letter. Then it says that vector simple A, vector A. I can notate this vector by using two capital letters. If not, I can use a simple letter. For example, vector simple B. You want to put a small line below the letter. This is about vector B. So vector notation clear. Vector graphical representation clear. Right, okay. For an example now, what you do? Shall we quickly represent some vectors? Now sample question one, quickly, okay? Without spending the time, sample question one. Everyone, please know these stories, okay? Know the stories. I'm not going to give a note, right? I'm not going to give a big note. Whatever the story I write in the board, you write down. Sample question one. Represent below vectors graphically. Sample question one. Represent below vectors graphically. Number one, write down. A 5 Newton force. A 5 Newton force acting on the object to the right side direction. Number one, a 5 Newton force acting on the object to the right side direction. A 5 Newton force acting on the object to the right side direction. Now represent that force vector graphically. That means, what do you mean by representing that force graphically? You should draw a line segment. Length of the line segment must be proportional to the magnitude of that force. So you want to use a scale, right? All levels you have learned in maths. Using a proper scale, start drawing a line segment. Horizontal vector acting right side direction. Magnitude of the force vector is how much? 5 Newton. So you can go for a scale. Example 1, you can go for a scale. Example 1, you can define 1 centimeter length in the line segment is proportional to 1 Newton. Then tell me, to represent force of magnitude 5 Newton, what should be the length of your line segment? To represent 5 Newton force, the required length of the line segment must be how much? 5 centimeter. Then what you do? You want to use your ruler and you want to exactly into a scale draw 5 centimeter line segment horizontal. But I can't use a ruler, therefore I just draw a line segment. But when you are drawing the diagram, you should take your ruler and you should measure the line segment. Exactly, length must be 5 centimeter. Then this is the length is 5 centimeter. Okay, when you take a ruler and when you measure the length 5 centimeter, right, direction is right side, use the arrow. To represent direction, right side. You can give a name for the vector. You can tell vector capital KL, vector capital AB. Vector AB. And this is going to be vector AB. Vector AB is how much? That is 5 Newton right side. 5 Newton right side direction. Simple. Likewise, second vector quickly write down. Second vector is write down, for example, second vector 10 Newton force acting in the northeast direction on the object. 10 Newton force acting on the object. 10 Newton force acting on the object in the northeast direction. Northeast. 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 Draw that graph. Draw that vector. Draw that vector. Start drawing that vector. Start drawing that vector. Start drawing. Start drawing. Start drawing next vector. Start drawing. Then second one is one northeast direction. So we all know north is upward direction. North. This is we call as south. North, south. This is east. This must be west. Then north east direction means this direction. Right? Then if you can remember all level knowledge, this is 45 degree. Then you should take your what? Protractor. You should take your protractor and you want to now what is the magnitude of the force? That is 10 Newton. Direction is what? In the northeast direction. Then you should exactly measure this angle 45 degree. You want to take your protractor and you should measure the angle exactly 45 degree. In the exam they ask you to represent the vector in a graphical manner. You should measure that angle using a protractor and you want to exactly that angle. Since I don't have a protractor, what shall I do? Right? I just draw another line segment. 10 Newton. Then you can go for a scale 1 centimeter equivalent to 2 newtons. To represent 10 Newton, what must be the length of the line segment? 5 centimeter. 1 centimeter equivalent to 2 newtons. Then to represent 10 Newton, the length of the line segment must be how much? 5 centimeter. This is your scale. And now what you can do? Exactly measure 45 degree, okay? Exactly measure 45 degree to the horizontal. This angle must be exactly 45 degree. Arrow is this direction. Length of the line segment must be how much? Exactly 5 centimeter. So you can name this vector as vector BC, vector CD, whatever. Vector C, vector D, vector CD. If not, you can use a simple letter. Simple letter, vector simple B. Likewise. This is the vector notation and vector representation. Clear? Vector notation, vector representation story. Okay? This story is all good. Simple, not difficult, simple. Simple? Simple. Now next theory. Now theory story 1. Now theory story 2. Next theory. Now multiplication of a vector by a negative sign. The multiplication of a vector by a scalar. Those theories. Next theory point. Remember, when you are multiplying a vector multiplication by a scalar. Next theory is vector multiplication. Okay? Vector multiplication. Next idea. Vector multiplication. Multiplication. Now briefly I'm explaining everything. Right? Briefly explain everything. Learn something from every story and clear it. Okay, vector multiplication. Now we can multiply a vector by a negative sign. Negative sign means you can take it as -1 for negative sign. Remember, if there is a given vector multiplied by negative sign, if there is a vector AB or whatever, if there is a vector, let's say vector AB, when you multiply the vector AB by a negative sign, remember what happens is only the direction of the vector changes. Okay. Before talking about vector multiplication, better if I explain about equality of two vectors. They will come to the story. Equality of two vectors. Equality of two vectors. Equality. Equality of two vectors. Equality of two vectors. Just consider now there are two vectors. There are two vectors. You can tell that vector AB, vector BC. If not vector simple A and vector simple B, there are two vectors. To consider those two vectors are to be equal, there are some conditions they must satisfy. The first condition is both the vectors must be homogeneous vectors. The first condition is, remember, they must be homogeneous. The first condition is both the vectors must be homogeneous. So what do we mean by homogeneous? Homogeneous means, remember, both vectors must be same type. That means we all know that force is a vector, velocity is a vector, right? Then do you think force vector and velocity vector, are they homogeneous? No, right? They are different types. To consider two vectors to be homogeneous, if your first vector is also a force, 5 Newton something, second vector also must be a force. Then only we can say both the vectors are homogeneous, same type of vectors. When you consider a force vector and velocity vector, they are not homogeneous, they are heterogeneous. They are heterogeneous, right? Therefore, homogeneous means same type of force and force vector, velocity and velocity vector, acceleration vector, same type. They must be homogeneous, that means same type. And the next one is they must be, both the vectors must be equal in magnitude. Homogeneous, they must be equal in magnitude. 5 Newton means other vector also must be 5 Newton magnitude, right? 1 ms minus 1 means other vector also should have same magnitude, 1 ms minus 1. Equal in magnitude. The next one is they must have same direction. Right, then they must be parallel as well. Fourth condition, they must be parallel, right? They must be parallel. Fourth one is they must be parallel. Listen. Now, shall I draw some two vectors? For example, now there is one vector. This vector is a force vector. It's 5 Newton. There is another vector that is also, this angle is theta. The angle made by this vector is theta. This vector is vector simple is something. There's another vector that is also same direction, but magnitude is 6 Newton. Angle same as theta. Then same type, homogeneous, because this vector also the force vector, this one also the force vector. Therefore, they are homogeneous. Remember, if one of the condition fails, right, even though 3 conditions are satisfied, and if one of the condition fails, we can't consider them as equal vectors. To consider two vectors are equal, definitely they must fulfill all the conditions. Yeah, homogeneous, okay. But magnitude of this vector is 5, this one is 6. Magnitude different, therefore these are not equal vectors. We can't consider these two vectors are equal, not equal vector. Right? Likewise, you can understand if I consider the two set of pairs. This vector also 5 Newton. Second one, this vector is 5 ms minus 1. Direction, same direction, right? Same direction, parallel, vertical, same magnitude. These 3 conditions are satisfied by these two vectors. But this is 5 Newton, a force vector. This one is 5 ms minus 1, a velocity vector. They are not homogeneous. Then they are not equal. Right? So likewise, some examples. Some stories, okay, some examples. Now this time, third example. Now there are two vectors like this. One vector is 10 Newton. This angle is how much? This angle is 30 degree, for example. The second vector is, that is also 10 Newton, but the angle to the horizontal is how much? Angle to the horizontal is how much? 6 degree. 60 degree. This angle 60. This vector is 10 Newton, angle 30 degree. This vector is 10 Newton, angle is 6 degree. Are these two vectors equal? Homogeneous, Newton, force vector, magnitude same, direction seem like same, but remember, angles different means remember, directions are different. Therefore, remember these two vectors are also not equal. Two equal two vectors, you want to understand they must be homogeneous, they must be parallel, they must be having same magnitude and same direction. This is the overall theory. This is the overall theory regarding equality of two vectors. You can understand the story. And then we talked about physical quantity, scalars, vectors idea, graphical representation, vector notation. Then we talked about equality of two vectors, right? And now we'll talk about vector multiplication. Vector multiplication. So we are doing questions. I think today, I'm not sure whether we can do questions, right? Today we are just starting only, right? Equality of two vectors. See the idea, this story. Now, if there is a vector and when you are multiplying a vector by a negative sign, you are multiplying a vector by a negative sign. When you multiply a vector by a negative sign, remember, what's really happening is only the direction changes, magnitude remains same. If there is a vector, when you multiply by a negative sign, the result is a new vector. The result is a new vector. Why? Direction changes. What happens? Direction becomes opposite. But magnitude is same. Magnitude is same, but direction is opposite. Same magnitude, but direction same. Sorry, my bad. Magnitude is same, but direction is opposite. Direction is opposite. Direction changed. That means, for an example, if there is a vector AB like this, there's a vector AB. This vector is vector AB. When you multiply this vector by a negative sign, if you multiply by a negative sign, if you multiply vector AB by negative sign, what will happen? Magnitude, that means the length of the line segment remains same, but direction becomes opposite. Now, before multiplying this vector by negative sign, direction is this direction. After multiplying it by negative sign, this one's direction is opposite now. Opposite now, right? Remember, just now we learned that when the direction changes, it's a new vector, right? When you multiply by negative sign, a given vector, if you multiply by negative sign, direction changes means this is a kind of new vector. New vector. This new vector. Direction is opposite now. Direction is opposite now. Then this point was point capital A, point capital B. You name this vector is vector AB. Arrow is going from A to B, vector AB. But now how we call this vector? Arrow is going from B to A. This vector is vector BA. This vector is vector AB. This vector is going to be vector BA. Remember first important story. The relationship between vector AB and vector BA is what? Vector BA means what? Minus vector AB. That's what remember. Very important. Very important story. Vector BA means, remember, that is equal to minus into vector AB. When you multiply vector AB by minus, the result is vector BA. When you multiply the vector AB by minus, the result is vector BA. This story is important. This story important. This story important. This story important. Right? This story important. Okay. When you multiply by a negative sign, this is the result. What if you multiply a vector by a scalar? Scalar means we can multiply vector by a positive scalar and we can multiply vector by a negative scalar. Plus 5, plus 3, plus 2, they are positive scalars. Minus 2, minus 5, minus 2, they are negative scalars. Next story. Multiplying a vector by a scalar. Next idea. Next theory story. Multiplying a vector by a scalar, next theory story. Multiplying a vector by a scalar, next theory story. What shall I do? I erase this side. This side erase. This side erase. Multiplying a vector by a scalar is story. Okay. Now right, I will give my WhatsApp number also in case if you want to clarify something, you can put a WhatsApp message, okay? You can put a WhatsApp message if you want to clarify something, right? Okay. Multiplying a vector by a scalar. This story. Next theory story. Multiplying by scalar. Multiplying by scalars. Right? First thing is multiplying by positive scalar. Multiplying by positive scalar. For example, plus 5, plus 2, plus 1, plus 8. Generally, okay, general scenario. Generally what happens if there is a vector, when you multiply by a positive scalar which is greater than 1 plus 1.5 plus 2 plus 3, magnitude of the vector changes but direction of the vector does not change. If there is a vector AB, for example, there's a vector in the beginning, vector AB. This vector has a magnitude and direction. You are multiplying the vector by a positive scalar. Multiplying the vector by a positive scalar, for example, plus 9, plus 8. This k is a positive scalar. Then remember, what will happen is the result is a new vector. When you multiply the vector by a positive scalar, magnitude of the vector will be changed. Therefore, there will be a new vector. There will be a new vector. Magnitude changes. In the result is, if you multiply a vector by a positive scalar, more than 1, magnitude changes. It's a new vector. The result is a new vector. New vector's magnitude is different. Magnitude changes, but direction remains same. The direction remains same. For example, just consider scalar as 5, 3, above 1, okay? Direction. That is remains same. Direction same. When you multiply a vector by a negative sign, magnitude is same, but direction is different, opposite. If you multiply a vector by a positive scalar, magnitude changes, but direction remains same. For an example, take an example. We'll take an example. There's a vector AB that is 5 Newton. There's a vector AB that is 5 Newton. Okay. For an example, if you take an example, there's a vector AB. It's a force vector. Its magnitude is 5 Newton. Its magnitude is 5 Newton. Magnitude is 5 Newton. So when you multiply this vector by a positive scalar, for example, you are multiplying by 3. Your positive scalar is 3. When you multiply by 3, what would happen for the magnitude of the new vector is, it is multiplied by 3. Magnitude of the previous vector is 5, you multiply by 3. Now magnitude of the new vector is how much? 5 into 3, 50 Newton. 50 Newton. Now length is large length. Why? Large magnitude. You can name this vector as vector, different vector, you can name different name. This vector is vector CD. You can give a different name for this new vector. For one can tell vector AC. And you can use different names for the vector. For one can define it as a simple A vector, simple B vector. A vector CD has a magnitude how much? That is, this is AB vector. This is AB vector. This is vector CD. CD vector has a magnitude how much? 50 Newton. 5 into 3, 15 Newton. Right? Other direction, simple. If they have given a vector and when you multiply the vector by a positive scalar, the result is a new vector. That new vector's magnitude is different, but its direction is same as before. So we can write down, in this scenario we can write down vector CD is how much? Vector CD is equal to 3 into vector AB. You understand that story? Some scenarios what we do, we can multiply vector by a scalar having negative scalar. Negative scalar. If you multiply a vector by a negative scalar, when you are multiplying a vector by a negative scalar, what will happen? negative scalar. For example, minus 3, minus 8, minus 20. In that case, remember magnitude as well as direction both changes. In the beginning, if you have a vector, if you have a vector in the beginning, vector AB, when you multiply the vector by the negative sign, when you multiply the vector by negative sign, negative scalar, negative scale, okay? So negative scalar, just generally put it as k. I generally put it as k, but it's a negative scalar, minus 5, minus 3. Then remember magnitude as well as direction changes. Magnitude as well as direction changes. Okay? Both changes. Both changes. Example, same story. Let's consider AB vector having 5 Newton force. AB vector having a magnitude 5 Newton. AB vector having a magnitude 5 Newton. If you multiply this vector by negative, multiplying by minus 3, then magnitude will be 15 Newton. Direction becomes opposite. If you multiply vector by a negative sign, direction becomes opposite. Because of the scalar, magnitude is also changed. The result is a new vector. Result is a new vector, vector CD something. Direction is this direction. Vector DC. Magnitude is 50 Newton. Story. Okay? Simple story. Real simple story. Real simple. These are the ideas. The main story clearly. Then summary. Summarize it. If we summarize it, what we learned today so far. So very simple story. It's not difficult. When you do questions, you'll understand more. Summarize it. So we started from the physical quantities. Any change, if we can measure it, they are physical quantities. For our easiness, we divided into two categories: vectors, scalars. Scalars having only the magnitude, vectors having magnitude as well as direction both. Now our topic is vectors, right? First of all, we want to understand how to represent a vector graphically using a line segment. Length must be proportional to the magnitude of the vector. Direction of the vector is pointed using an arrow. Then how we represent a vector notation? How are you going to give a name for the vector? There are two options. You can use two capital letters. But when using two capital letters, you want to mention an arrow on top of those two capital letters. Option number 2 is you can use a single simple letter. When you're using a single simple letter to rotate a vector, you should use a small line segment. That's story. Okay. Then we talked about to consider two vectors to be equal, they must be homogeneous, they must be equal magnitude, they must be equal in direction, they must be parallel. Right? Then we talked about vector multiplication. In that case, we can multiply a vector by negative sign, we can multiply a vector by positive scalar, negative scalar, stories. This is the overall idea. This is overall idea regarding the story. Very simple story. Really simple story. Now, this is stage 1. Stage 1 theories are done. Now we'll talk about stage 2 theories. Stage 2 theories. Stage 2 theories. Stage 2 theories. Need a small break. Stage 2 theories. Stage 2 theories. Right? 8:45. So we are stopping the class at 9:30 today. Right? Stage 2 theories. Stage 2 theories. Right? So quickly note down these important things. I will give some time. I will give maximum 2 minutes. Within that given 2 minutes, write this story. This covers entire theories. Don't worry. This story covers entire theory. Normally in our theory classes, we take around 4 to 5 weeks to complete vectors. But today we are starting slowly. Normally one session for one chapter. I will increase the duration to 2 hours upcoming days. Right? Normally 1 day for one chapter. Plan is within 2.5 months. Completing need to mainly as our plan. Okay. I'll give 2 minutes, complete it quickly. I'll give 2 minutes, complete quickly. 2 minutes, complete it quickly, 2 minutes. Two minutes, complete it quickly. quickly write and finish writing. Okay, quickly write down the stories, then next story, next idea. Right. So then I'm erasing the board. Next story is important story. We'll talk about vector addition, triangular law, very popular, parallelogram law, polygon law stories. Those are really important theories, right? Now I'm going to explain those stories only now. Now stories. Okay. We talked about vector multiplication. Now we'll talk about vector addition. Right. Now O-level maths, when you were a kid and when you were learning the maths, so you learned operations like addition, subtraction, multiplication, division, right? So very similar thing. You are learning vectors as the first time, I think. All levels you learn, but not to this level, up to some level, right? Now we are thinking that you are a kid, like how you learned all level maths, addition, subtraction. Now vectors is not scalar. Like how we add scalars, 2 plus 3 is 5, 9 plus 10, 11, 9 minus 2, 7. Right? Like how we subtract, add, multiply, divide, we can't add, subtract, multiply, divide vectors like that. The way we are doing the operations like addition, subtraction, multiplication, division for the scalars, and the way we follow addition, subtraction, multiplication, division for the vectors are different. So what we are doing, I'm explaining step by step. If you want to multiply a vector, what will happen? When you're adding a vector, what will happen? When you subtract vectors, what will happen? So we are learning the things from the beginning. Next idea. Next idea. Next theory. Next theory. Now I'll share the tude PDF in the WhatsApp group after doing this triangle law story. We can do some MCQs. Then we'll talk about next theories. Right? Okay. Okay. Right, okay. And now vector addition. Vector addition. If not, that is what we call as the resultant of two vector. Okay, vector addition. We can add two or more than two vectors in two different methods. One is really time-consuming method, really time-consuming and really boring method, that is addition of vectors using graphical methods. Addition, now vector addition, you can add two or more than two vectors using two different methods. One is graphical methods. Method number two is algebraic method, calculation equation methods. When it comes to graphical methods to add two or more than two vectors, there are three methods. If you want to add two vectors, we can use triangle law of vector addition. If not, parallelogram law of vector addition. But in case if you want to add more than two vectors, for example, there are three vectors, four vectors, five vectors, you want to add them together. In that case, we can use that polygon law of vector addition. Right, now we'll talk about the way how to find the addition of vectors graphically. Vector addition, graphical methods. This is somewhat important. These theories are really important. Some theory points, okay? Theory point. Theory point, I take it as theory point number one, main stories. Previous ones are definitions. Now main theory point, stay focused. Time is 8:50, maximum another 20-25 minutes, then finished. Theory points. So I will post the tudes for the required people. Theory points. Number one is vector addition story. Theory point number one, vector addition. How do we add vectors? So scalars we learned in our O levels. We know that how to add scalars. 25 plus 1 is 26. Like this, we can't add vectors. If there are two vectors like this is 5 Newton and this is 6 Newton. You can't tell that what is the addition of these two vectors. You can't tell 5 plus 6 is 11. You can't say 11. Why? These are not scalars. These are different people than scalars. In scalars only you can add that 25 plus 1, 26. In vectors, you can't add 5 plus 6 is 7. You can't do like that. Vector addition, next story. It's very important. Generally, there will be one MCQ in your LL paper. Generally, there is one MCQ in your LL paper from vectors. But that MCQ you must score. You should score that MCQ. Comparing with other MCQ, generally this MCQ from vector section comes between MCQ number 1 to 5. The first 10 MCQs, we all know that they are easy MCQs. Definitely, if you are planning to get a, you should score 10 out of 10 in first 10 MCQs. So therefore, you should, no matter, even one MCQ comes from this chapter, you must get that 1 marks. One MCQ is, remember, 1 marks out of 100. Okay, vector addition. Now, method 1 is triangle law of vector addition. We can do some questions hereafter. Method 1 is triangle law. Triangle law of vector addition. Triangle law of vector addition. Triangle law of vector addition. The first important thing is, remember, this triangle law method is only applicable to find the addition of two vectors. You can't add more than two vectors by following triangle law. Therefore, the important thing is only for two vectors. If you want to add only two vectors, you can use triangle law. Only for two vectors. Only for two vectors. Right? Only for two vectors. Right. Now, what is the idea behind triangle law? So, I will take an example and I will show you. Now, there are two forces. We know forces are vectors. There's an object. There are two forces acting on the object. There are two forces. Forces are vectors. Two forces acting on the object. One is applying a force horizontally. Another one is applying a force on the object in the inclined direction. Take like that. Take like that, this story. This story is important. Very, very important. Put a star here. It's a star theory point. Okay, right. Now there's an object. Okay, there's an object. Okay. Mass is simple in whatever. It's not important actually. One force applied on the object is right side direction. It's a vector. I can name this vector using single simple letter or two capital letters. I use simple A, simple A, vector simple A. It's a horizontal vector, right side direction, acting right side direction on simple A. Think it's a force something. The second vector is acting on the object. The second force acting on the object is this direction. Simple B vector. The name is simple B vector. You can use two capital letters also to represent the vector, but I'll use simple letters. Vector simple B. There are two vectors. So now in the exams, they can ask you what is the addition of these two vectors. Now in that case, we can use triangle law of vector addition. See the way what I'm doing. Triangle law says that this angle they have given, this angle is theta. Angle made by vector B to the horizontal is theta. Now triangle law says that you want to complete a triangle. But when you are completing the triangle, you should follow these stories. What stories? They are telling when you are starting to draw the triangle, you can start from any of the vector. Into a proper scale, you should define the scale. Into a proper scale, you should draw these line segments. You should measure the angle also properly. Because we are talking about graphical representation. Graphically how to find the resultant. Graphically how to find the addition. Therefore, you want to represent, for an example, if it's 5 Newton means, you should use a length segment proportional to 5 Newton. If vector B is, for an example, 50 Newton, the length should be proportional to that 50 Newton. Okay? Remember, when you're drawing the triangle, you must draw into a scale. Clearly, simple. Now, you can start from any of the vector. I can start to draw the triangle from vector A. If not, I can start to draw the vector triangle from vector B. It's up to you. I'll start from vector A into a proper scale, start drawing the first vector. So horizontal one, a horizontal vector. Horizontal vector. So horizontal vector. Simple. Arrow is right side. This vector simple A. I started drawing this vector from this point, initial point is this one. Final point of this vector simple is this point. Triangle law explains that from the point where you finish drawing the first vector, start drawing your second vector. From the point where you finish drawing the first vector here, start drawing a second vector into a scale. Into a scale. Start drawing second vector into a scale. Then sir, this vector, this way, into a scale. Right, I started drawing simple B vector from this point, simple B. So overall, initial point, this is the initial point. Initial point. This belongs to the final point. Final point. This belongs to final point. Final point. Final point. After completely drawing those two vectors, but you want to consider one important point. When you are drawing the vectors, the arrows must flow in same direction. Arrows are flowing same direction. Like a snake, how snake is moving, arrows must flow in same direction. Right? In case if this arrow is this direction, then arrows are not flowing same direction. Arrows are meeting. Then they say that when you connect initial point and final point together by using a straight line. When you connect initial point and final point together by using a straight line. By using straight line. Initial point to final point, that is your addition of these two vectors. Remember, addition of two vectors is also a new vector. Addition of these two vectors is also a new vector. That is this blue color vector. You can see this vector is vector simple C. Vector simple C. If I using some capital letters, this point is point capital A. Start from point capital A. This is point capital B. Point capital C. Vector simple A means vector AB. Vector simple B means vector BC. So you can tell that vector AB plus vector AB plus vector BC, that must be equal to what? Addition of these two vectors equals to the new vector, AC vector. AC vector. If not, vector simple A plus vector simple B must be equal to vector simple C. Addition of vector A and B is equal to C. This is the idea. It's a triangle, very simple. Really simple story. Next theory. Next one is, the second method is, you can use that parallelogram law of vector addition. It's triangle law. If there is two vectors, that is also applicable to add the two vectors. You can use parallelogram law of vector addition, that's theory. Parallelogram law of vector addition, next theory. Second story, parallelogram law. Right, number 2. Triangle law discussed. Second one is parallelogram law. Parallelogram law. Parallelogram law. Okay. Now also same story. There are two forces acting on simple mass. Now they say that draw these two vectors into a scale such a way diverging from a common point. You should start drawing these two vectors as two sides of parallelogram. You all know this is a parallelogram. You should start drawing those two vectors as two sides of parallelogram such a way diverging from a common point. These two must be the two sides of parallelogram. They must diverge from a common point. Then I can draw these two vectors like this only. Then I can draw vector simply into a scale like this. Vector simple B diverge from a common point. Those two must be the two adjacent sides of the parallelogram. Vector simple B. Now see. Right. Two vectors represent two sides of a parallelogram diverging from a common point. Then first is they are telling that first of all represent those two vectors as two sides of a parallelogram such a way diverging from a common point. Clearly. Then they tell that step number 2, complete the parallelogram. All level maths. Complete the parallelogram. Complete the parallelogram. Complete the parallelogram. Complete the parallelogram. By using dotted lines, complete your parallelogram. I have completed. Then they say that after completing a parallelogram, when you consider the diagonal passing through the common point to the opposite point, the diagonal passing to that common point to the opposite point is the addition of these two vectors. Is the addition of these two vectors. Addition of these two vectors. The vector A plus vector B is this one. Vector C. If not vector C, that is the vector A plus B. A plus B. Simple. Simple. Simple story. Then these two laws are only applicable for adding two vectors. Only for two vectors. Only for two vectors. So what if there are more number of forces acting on the object? In the vector system, if there are more than two vectors, how to add them together? In that case only, we are using Polygon law. Polygon law of vector addition is applicable more than two vectors. Polygon law story. Polygon law is also some kind of triangle law only. Look at this idea. Now we can do some questions. I will share the tut also in the group. The tut PDF in the group. WhatsApp group. Tut PDF I will share in the WhatsApp group. Next story, Polygon law. Polygon law. Third one is Polygon law. What we are talking now? Now previously we talked about multiplication of vectors. Multiply by negative sign, multiply by positive scalar, multiply by negative scalar. Now we are talking about addition of vectors. Adding two vectors using triangle law. Adding two vectors using parallelogram law. Now we are going to add more than two vectors using Polygon law. Polygon law. Adding vectors using Polygon law. P-O-L-Y, Polygon law. Polygon law. Polygon law. Right? Idea. So for an example, let's consider. Now we'll take it as there are four vectors acting on the object. If not, you can use three vectors also. More than two vectors. I will consider three vectors. If not, you can use four vectors, five vectors. It's up to you. Right? Polygon law. See the idea? Polygon law. Polygon law story. Now on this object simple limb, there are three forces acting on the simple limb object. One is vector simple A, right side. The second vector simple B, this direction. The third vector is vector simple C. This angle we know is theta. The third vector is vector simple C acting on the object, this direction. This direction. This angle is alpha. This angle alpha. Likewise, we can draw many vectors. 3 is enough. Vector simple C. Right, vector simple C. If not, I use any vector. Now, don't you misunderstand here. Vector C means addition of these two vectors. But here, vector C is another vector acting on simple limb. Now, Polygon law says that again, you have freedom to start from drawing the diagram into a proper scale, measuring the angles using the protractor. You want to know the diagram. You can start from any of the vector. One can start from vector A, one can start from vector B. If you like to start from vector C, you can start from vector C also, no issue. But we'll start from vector A, then B, then C. You start drawing the diagram from vector A. Horizontal vector. Horizontal vector is simple A. Start from this point. This is the point where you finish drawing the first vector. And start drawing a second vector from the point you finish drawing the first vector. This point. I'm starting vector simple B. Vector simple B like this. Vector simple B like this. Vector simple B. But you want to measure the angles properly, then only you get the right answer. It's theta angle. From the point I finished drawing the second vector, you should start doing the third vector. But you want to ensure arrows are flowing in same direction. Like a snake, arrows must flow in same direction. Arrows can't be opposite. This is this direction. This one's arrow is right direction. This one arrow is this direction. It can't be. It should not be. Then it's wrong. The vector C. From this point, I should draw the vector C. Then vector C this way. This way, for an example. Vector C. This angle alpha. I started from this point. I finished from this point. Initial to final point, when you draw a line segment, a straight line. This is going to be what? The resultant. The addition of these three vectors. Vector A plus, vector B plus, vector C. This is going to be the addition of these three vectors. Vector A plus, vector B plus, vector C is this new vector. This new vector. From this theory, now we can do these questions. Now simply, that's it. Addition of vectors using graphical methods. Now thereafter, I will teach you addition of vectors using the equations. Before doing that, we'll do few questions and we'll get the idea. I share the PDF in the group, refer it. If I share the PDF in the WhatsApp group, refer it. I share the PDF in the WhatsApp group, refer it. The PDF in the WhatsApp group. I shared. Time is 9:06. So we are doing the class till maximum 9:30 only. I told to do that, but sometimes I might stop early, something. Next day onwards, we are planning properly, we are doing. Sometimes I will put an extra session also, and we are completing because our goal is very simple. Every theory point once again briefly explaining, and we are doing some questions also. We are not avoiding doing questions, we are doing questions also because questions are important. It's a kind of fast track story. That means we don't take that much of explanations like theory classes, but what is important we are quickly explaining, and we are doing not that much questions, but we are doing considerable number of questions in the class, and we want to bring everyone to the right track. That's the important thing. It's completely all right. Now one story I will tell you. Now I don't know how many of you really you might have, because you are joining for a fast track means there have been some reasons. Now most of you joining for a fast track sessions like this, what intention? Definitely you might have messed up with the previous stories. If not, even though you cover the previous stories, still you are not that much confident sometimes because you are not working properly. Sometimes the way that you're learning from your teachers is not suitable for you. There are some reasons like that. Very rarely only some students, they join for such sessions to revise the things once again. But people who work so far already, normally they don't even join to revise them also. Some people, they join to revise it, but most of the people, they are joining because they messed up, right? They fully missed those stories. So at least now we have enough time. Now I don't tell you to work with me. We have enough, you all have enough time, right? Because just now A-level started, I think you started your A-levels 2027, 2026 last year. This 2025 April only your batch started. You have exactly 1 year and 8 months still. You have exactly 1.5 years roughly. So therefore, even I say that 6 months is more than enough for the one who are ready to work. 6 months more than enough to get A. Therefore, you have more than 1.5 years. That means triple. 6 into 3, near around 1.5 years. So therefore, even you start from now also, you can work nicely. But one is important. Physics is all about exposing to applications. When we understand physics subject, when we are exposed into application, we are learning theory. I know that everyone understands theory. I know everyone understands theory. But the problem is what? Most of them understand theory. When it comes to questions, they can't do. Right? We should expose to number of questions also important. But sometimes same type of question is repeated to 100 times. That's also not a point. That's also wrong. Right? You want to expose different questions in different application. So when you expose into different applications only, you will at a point suddenly you don't get to understand everything. Suddenly you can't do the questions also as soon as possible. But if you are in the right track and if you are working for around 6 months, definitely you can see a result. Right? After you started, after you understood and after you got to know that you can do a question, thereafter you will understand physics very easily. Right? Even people got 9As also, they can't understand theories in the beginning. The reason is what? It takes some time to process your brain to think physics stories, physics applications. Therefore, the best thing is expose lots of questions having different applications. That's the most important thing. Right? That story. Okay, right. I'll share the PDF in the group and we'll do some questions. I share in the PDF. Just go to the PDF. So when you go to the PDF, we'll just do some question related to triangle law, parallelogram law and polygon law today. triangle law, parallelogram law, polygon law today, go to the TUTE PDF page number, 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 PDF page number. Okay. Page number 13, question number 39. Page number 13, question number 39. Page number 35, question number, page number 13, question number 39. Then question number 35. 39, 35. Questions 39, 35. 39, 35. Then we'll do some questions. Then we'll do some questions. There are lots of questions. We'll do some questions regarding polygon law. Polygon law questions. Some beautiful questions. Page number 17, question number 60 also we can try. But easy one. 13. 13 and 12. We'll do 13 and 12. We'll do 13 and 12. Okay. We'll do 13, then 12, then 60. 13, 12, 60. 13, 12, 60. This one belongs to triangle law, polygon law. These three, this is triangle law, parallelogram law. This three belongs to polygon law. Let's give a small time. Just give a small try. I will give some time. Not that much time. I will give 1 or 2 minutes and I will start explaining the ideas. Give a try. Just give a try. Just give a try. Just give a try. If you want to contact, I'll put my WhatsApp number once again. Give a small try. Give a small try. Just give a small try. Okay. Now 39 story. Page number PDF 39 story. 39 story. 39 question. That is about triangle law. Two forces 3 Newton, 4 Newton act perpendicularly on the object. The vector diagram that accurately gives the magnitude and direction of the resultant of those two forces. Now they have given 3 Newton right side. There are two vectors. 3 Newton right side, 4 Newton downwards. See, question number 39. Question number 39. 3 Newton right side. And 4 Newton downwards. This is 9 degree. They are asking which of the following diagrams best represents the addition of these two vectors. They are asking the magnitude and direction of the resultant of these two, means addition of these two. You find which diagram gives the addition of these two vectors properly. Addition of these two vectors properly. Okay, which diagram? Which diagram? Now, now story. Now story. Which one? Now one can start drawing the vector diagram from this one, but based on the given options, they apply triangle law by starting from this vector, 4 and vector. Now I am using the same story, triangle law. By using triangle law, I am going to find the addition of these two vectors. 4 Newton downwards. Ni. Starting from 4 Newton downwards. Start from here, finish drawing at here. From the point where you finish drawing the first vector, start drawing second vector, 3 right side. 3 right side. Yes, arrows are flowing same direction only. Then initial point is here, final point is here. When you connect the initial point and final point together, initial and final point together, that is going to be the initial to final point. Initial is here, final point is here. Initial to final point is the resultant vector from addition of these two vectors. O-level maths. Direction of the addition of this vector is this direction. Can someone tell the magnitude of this vector? This vector magnitude is, you can use Pythagoras theorem. Magnitude of this vector is listed as simple x. Pythagoras theorem, we all know that. Hypotenuse squared equals 4 squared plus 3 squared. 4 squared plus 3 squared. 16 plus 9. That means 25. X squared is 25. When you substitute simple x, that is how much? When you substitute simple x, that is how much? That is going to be x must be 285 centimeter 5 ni. When you substitute x, square 25 means 5. X is 5 newtons. Simple ni. Simple. Therefore this must be 5 Newton. Done ni. Then the right answer, that question right answer is I think fourth one ni. This question number 39, right answer is fourth one. Right answer fourth one, 1, 2, 3, fourth one is the right answer. Simple ni. Likewise, start doing 35, that is parallelogram law question. Start doing 35, that is parallelogram law question. 35, that is parallelogram law question. Simple. Simple. 35. Which of the following figure correctly represent the two vectors P and Q and their addition P and Q? Then by looking at the diagram, you can tell that it must be third one. Vector P and vector Q. Addition of vector P and vector Q. See, third one is the answer. Vector P is vector Q. Vector P, vector Q. Complete the parallelogram. Once you complete the parallelogram, the diagonal passing through the common point to the opposite point is the addition of these two vectors. This is what? Addition of these two vectors. P plus Q. Simple. Then 13, 12. 13, 12 stories. Start doing 13, 12. Start doing 13, 12 stories. Start doing 13 story. The third idea, polygon law. Nice question, nice question. Somewhat different than these two questions. Nice question. Stay focused and learn. Stay focused and learn. That's the story. 13 story. 13. 13. Now they have given set of vectors. They have given set of vectors and they are asking us to find the addition of those vectors. They are asking addition of those vectors. Resultant of those vectors means addition of those vectors. Story. Next I will explain properly. Now there are a set of vectors, really confusing diagram. I will do the diagram first. If I do the diagram first. A diagram like this. If I do the diagram properly, I use two different colors to differentiate some stories. This is the diagram. There are many vectors in the system. There are more than two vectors. So we can see there are more than, this is a vector, this vector, this vector, this is a vector, This is also a vector. There are, I think, altogether 1, 2, 3, 4, 5, 6. There are 6 vectors. And they have given them some points, point capital A, B. This point is A, this point is B, this point is C. Right? This point is D and E. This point is D, this point capital E, point capital F. Sometimes when you're finding the addition of set of vectors, in that set of vectors, you may have to apply polygon law. Again, you may have to apply triangle law. You might have to apply triangle law, polygon law for 2 scenarios. This is like that, kind of complicated question, but anyone can understand. Now, look very carefully, this blue color 2 vectors, ED and DC vector. When you consider these 2 blue color vectors, ED and DC vector, they are obeying the triangle law. Triangle law says that when 2 vectors are represented by 2 sides of a triangle, if their arrows are arranged in same direction, ED from the point you finish drawing the ED vector, point D, start drawing the second vector DC. Don't think about these black color vectors, only think about ED, DE. These 2 vectors are following the triangle law. Start from drawing ED vector, from the point you finish drawing the ED vector from point D, you start drawing DC vector. Then we know that triangle law says that initial to final point is the resultant addition. Initial to final point, the straight line is the addition of these 2 vectors. Therefore, what I am doing, what I am doing, the straight line, okay? This is the addition, additions, EC vector. This red color one is the addition of ED and DC vectors. So what you can do, remember, instead of drawing these 2 blue color vectors, you can only draw the red color addition of those 2 vectors, EC. So if you add these 2 blue color vectors, the result is EC vector. Okay? And now, now there is EC vector, addition of those 2 blue color vectors previously I marked. Now think about 3 vectors. Now this EF, polygon law. EF vector, from the point I finished drawing EF vector, point F, I start drawing the second vector FA, polygon law. From the point I finished drawing the FA vector, I started drawing AB vector, arrows are flowing same direction. From the point I finished drawing AF vector, point B, I start drawing the next vector BC. When you consider EFA, EF, FA, AB, BC, 4 vectors, when you apply polygon law, the result is what? The addition of these 4 vectors, initial point is here, final point is here, again easy. The addition of these 4 vectors is how much? I told you initial to final point. Don't think of anything else. Initial to final point, the straight line is addition of these 3 vectors. These 4 vectors, initial point is here, final point is here. If you connect them together, blue color one is the addition of these 4 vectors. Finally, now we can see red color EC vector, blue color EC vector. There are 2 vectors right side direction. Red color EC, blue color EC right side means what is the addition of these 2 vectors? 2 EC vector. That's it. That's it. Simple story. I think we have given a good explanation for this story. Right, next day we are planning something big. Right, normally in the online classes I ask you your doubts and clarify your doubts. Upcoming days we'll arrange a kind of interactive session. We'll ask doubts and we'll clarify and we'll finish this fast track session conducting for Unit 2 mechanics nicely. Right, so then I think everything is very clear. If you have any doubts you can ask, you can put a WhatsApp message, you can ask and clarify everything. Right, learn everything properly. When you learn everything properly, there is no issue. We want to expose more number of questions, short note methods. Those things are number 2 only. Number 1 is understand the theory properly. Then expose it to lots of questions, because our minds are adjusted. When we do lots of questions only, we will be able to understand some tiny tricky stories. So therefore, idea is clear. Study well. We'll stop for today. I think we have conducted the day okay, nice. Next day we'll start from the remaining story vectors, and next day we'll start linear motion theories. Then we'll meet the most important story. We'll stop the class for today. Then study will have fun.